So in this question, we're going to look at trigonometric function and we're going to look at differentiation, so at calculus creating derivative, and as well integration, so go in kind of both direction. Okay, let's see. The function h of x is defined for x belong to R as, and that's what we have, it's a sin function. So first thing we have to write down what the derivative of hx. How do we do derivative? We know each element, which in this case is one element. How do we know elements? Plus and minus. Well, unless it's a function multiplied by a function anyway. How do we do that? We go to our table, we look for the appropriate formula, isn't it? So where is our derivative? So here it is, our fx, our given function is sin of x, and therefore derivative will be cos of x. Now the problem with that is that here we have x only. But in our example, we have more than x. We have 2x. Now, what that means, we have a function within a function because 2x on its own, it's a linear function, isn't it? So that means we are multiplying, we deriving it as if it was only sin x. So that will be cos 2x multiply, and then chain rule. We are applying the chain rule, so basically multiplying by the derivative of that function within, which is 2. So our full derivative, that is 2 multiplied by cos of 2x. Now, that was simple enough. Nice. Let's have a look at next part where he's saying use integration to find the average value of our function in a given interval. Okay, so how do we find the average value? Average value of function, any function. So the way we do, first we have a fraction where we have high value of interval, low value of interval. Then we are saying we're going to integrate given function. So we are treating given function as a derivative. In the next step, we integrate, meaning what in practice? We are applying the formulas. Oh yeah, that's within interval. And then in the next part, we're going to find the value now that we have original function. So with that value, we take our original function, we replace x with higher interval, minus we take again our function, and we replace x with lower interval. And that's how we find the value. Okay, so let's apply that here. So in this case, it's 1 over pi over 6 is a higher number, minus 0, that's a lower number. And we're saying we're going to integrate within that our interval a function sin 2x, and we are saying dx, we are saying this derivative. That's the reason why we are putting dx here. So again, how do we do that? Well, we are applying formula here. Again, the problem is that in your table, when it comes to the formulas that has to do with integration, so we have our sin of x is saying it's becoming minus cos of x, but we know we have more than just x. What happened with this a here? So when I am integrating a function that have sin and have more than just x, when I'm integrating that a here, that value goes in front as a fraction. And then the rest is the same cos of ax. So that's what, now this is not in your table, obviously, so you need to know that for your exam. So let's apply that. That's 1 over pi over 6, because minus 0 will be just pi over 6. And we are applying our formula. So that means minus 1 over 2, because that's the value that stands beside x, multiply by cos, and angle doesn't change, 2x, and that is within that interval pi over 6 and 0. So now we are going to the third part where we are finding the value. So now we are taking our function and we're going to replace x with a higher interval, so pi over 6, minus, and again that same function, minus a half multiplied by cos 2 multiply, and here we are replacing x with the lower interval 0. Now, the problem we are having here, now all of those are numbers. We can put all of that in the calculator. The problem here is we're going to get a decimal when we put that in our calculator. And in our question, they did not specify how we should give our answer. Okay, so can we give different answer? Can we break it down a little bit? Yeah, of course we can. So here I have 1 divided by pi over 6, and that is multiply. And then let's deal with our bracket. I have a half multiply, and then I can put that in my calculator and I get a half. Don't forget your calculator have to be in radians because this angle is in radians, yeah? And then what? Minus, and then a half minus a half. Let's put that in the bracket so we don't get confused. And again, we put that in the calculator and we get 1. Okay? Don't assume that cos or sin of 0 will be 0. Not always, like in this case, not 0. So now I'm saying, okay, all of that, I can get a number because they are now numbers, right? So here I have 1 multiply. If we are dividing the fraction, we multiply and turn it upside down. Multiply, and when we put all of that in the calculator, we get 1 over 4. So really 1 multiplied by the rest is the rest, doesn't matter. Now here what I can do, 6 divided by 4, that's what? Both of them divide by 2, so here I can have 3, here I can have 2. So that means on top of the fraction 3 multiplied by 1, that's 3. On the bottom of the fraction 2 multiplied by pi, so 2 pi. So that is our answer here. Yeah, so like I'm saying, all good apart from that little bit at the end to find the value.